Hello, everyone. Welcome to this session today on deep dive into leveraging AWS Secrets Manager with cross-account AWS KMS keys. So to introduce ourselves, my name is Sarah Curry. I'm a security consultant within professional services. We work with customers to help architect and implement technically excellent security solutions to help support different customer initiatives that are meaningful to their business and their outcomes. And I'd also like to pass it over to Johnny to introduce yourself.
Hi, my name is Johnny Ray, and I am a security engineer with AWS Managed Services. And AWS Managed Services, also known as AMS, is responsible for operating customers' workloads within AWS. And I'll be presenting the AMS, providing an overview of the AMS use case later in the presentation. But for now, I'll hand it back over to Sarah.
Thanks so much, Johnny. So for today, as we know, a lot of companies are growing into multiple AWS accounts. They find that they need to securely implement credential sharing across their accounts and with partners. So this session, we're going to explore how you can leverage AWS Secrets Manager with cross-account AWS KMS keys to store, rotate, manage, and retrieve many different types of secrets. So you'll see that we're going to go over a customer use case, also some tips for implementing the solution. Johnny will be going over the AMS use case. We'll go over some key takeaways and some additional resources. And I do want to note that this is a 300 level session. So we expect that whoever is watching this is familiar with AWS Secrets Manager and Amazon KMS keys. So again, like I mentioned, why is this a solution that we needed to look into? So many companies are growing into multiple AWS accounts because they either want to isolate different business or units and organizational units and cost centers. They also want to make sure that they are going to be able to securely implement credential sharing across different accounts, or if they have any partners that they are working with in their AWS account. And the reason they'd want to do this is essentially monitoring the access between these different credentials all across their multiple AWS accounts. We're also seeing, again, the need to implement secure transfer of information, but with least privileged permissions. So again, if you're having different types of business teams or managed service providers that need access to information, companies are still going to want to practice best security practices with least privilege permissions. So if they have any handoffs for applications or operationals, they're going to want to make sure that they're preventing creation of policies that grant overly broad access to your secrets, and also configuring AWS KMS and IAM services and policies in place to ensure, again, that only the correct permissions are in place that are needed. And additionally, customers are really wanting to focus on ensuring there's little to no downtime during any secrets rotations. So they're wanting to rotate their secrets at scale and have a consistent way to manage these different credentials. So we're going to start off with a customer use case. So at AWS, customers are at the heart of everything we do. So we wanted to start with a use case to help understand the importance of governing and encrypting at scale. We're going to dive deep into tangible, results-focused example of how your organization can use AWS services to give you a better understanding of how your company can apply the same or similar solution for your business needs. So we're going to dive in with one of my favorite customers, Change Healthcare. So a little bit about Change Healthcare, or CHC. Change Healthcare is one of the largest health administrative networks in the United States. They help process claims, pharmacy requests, and perform other functions for more than 340,000 physicians and 60,000 pharmacies. Change Healthcare also uses AWS to handle millions of confidential transactions daily from its clients while maintaining with full compliance to healthcare industry regulations such as HIPAA and PCI compliance. And by using AWS, Change Healthcare can develop and test new services for its customers quickly and can scale to meet large demand while minimizing its IT costs and complexity. So let's talk about their use case. So we know, again, that Change Healthcare is a big company. So they're going to have hundreds of different teams and accounts across a lot of different business units and different cost centers that they need to monitor. And a lot of these accounts and teams are going to have multiple accounts in terms of production, pre-production, development, UAT. So there's a lot of different aspects when it comes to managing all of these different accounts. And one of the services that they use is AWS Organization, so that they can go in and simply implement controls across all of their different organizational units, and have insight into different monitoring aspects of it. And again, they're going to need to manage a variety of credentials. So something that Change Healthcare focuses on a lot are different types of credentials, such as database, API keys, Git credentials, application credentials, tokens. I'm sure things that you also have to deal with in your day-to-day for your company. So let's talk about some of these business needs. It's important to consider that, as the number of your AWS accounts grow, customers will need to structure their governance at scale to be agile. So you might be asking yourself, why would we need to share credentials? Normally you hear do not share credentials with anyone. However, this is going to be a way that you can securely share those credentials to offer these privilege permissions. So let's dive into some different business needs. So first off, we have a database architect, and she needs to be able to share the database credentials with the applications. So essentially, this will be her use case for why she needs to access the cross-account credentials from another account with the application. Additionally, we have a security engineer, and this security engineer, he needs to monitor access across a bunch of different accounts and create disable keys and rotate them. And he does this in order to help isolate accounts and have different best security practices in terms of monitoring these different accounts, and they can disable credentials if there's any malicious activity detected. And then we also have the information security director. So this person was dealing with paper-based audit trails that were insufficient to provide visibility into the use of secrets. So they needed access to pull evidence for audits compliance for their highly regulated industry for different compliance with, again, HIPAA or PCI compliance. And then we also had the managed service provider. So Change Healthcare was utilizing AMS to help speed up the acceleration of their migration. So in this instance, AMS was helping Change Healthcare to meet their deadline to exit their data center by providing partial operational responsibility for their environments during the migration. So the managed service provider, AMS, needed limited access to Amazon EC2 instances. Additionally, we have a developer that needs to connect to credentials for connecting to the database, as well as rotating secrets every 90 days so that they can meet the compliance requirements that the InfoSec director has put in place for their specific application team. And lastly, we have middleware that needs to connect to credentials, to connect to all different types of services. So I'm sure that you or someone in your company that can relate to one of these business needs in terms of credential sharing. So let's dive into how we solved this with AWS Services. So this is a high-level overview. So we used AWS KMS keys, where essentially we dived into limiting permissions and managing the cryptographic material. We also had AWS Secrets Manager to manage and store and rotate keys within the different applications and databases. And with that, we used AWS Lambda, which includes Lambda functions that you can integrate or create your own custom Lambda functions to rotate secrets and help ensure that you have those rotating on the specific periodic basis that it's needed for your industry standards. And then lastly, we implemented monitoring with AWS Config. So this is how we set up different essentially configurations to check to see if the resources were in compliance. And if not, alerts would go through CloudWatch events and send notifications to Change Healthcare. So let's dive in and we'll go into the details of the specific solution. So let's walk through the full solution, and we're going to discuss about Change Healthcare's architected solution that best met their needs. So we first started out with IAM, and we created that secrets policy that's going to AWS Secrets Manager to allow permissions for the SecOps role. We also created a KMS policy to allow IAM users and groups and roles to connect to AWS KMS. And from here, you can see we have the centralized security account. And with AWS KMS, we use the permissions and also created a KMS key. So from here, this KMS key is owned by the customer, and they can create and delete and manage their specific KMS key. So from here, we had the KMS key being encrypted with AWS Secrets Manager with the AWS CLI. So that's the command line interface. And that is so that we can encrypt the key with the cross-account information that we're sharing in the different account. And from here, we created more IAM policies with Lambda so that we're connecting AWS Secrets Manager, giving it a role access base to AWS Lambda. And we have the Lambda Secrets function that was integrated with AWS Secrets Manager to go to Amazon RDS, the database that Change Healthcare chose to use on the backend, and had a secrets policy so that RDS could connect with Secrets Manager. And from here, we also configured our monitoring aspects. So again, like I mentioned before, AWS config, we set up rules. There are conformance packs. So there's a HIPAA conformance pack, there's managed rules and custom rules. So from here, we actually used a managed rule to check to ensure that all of the secrets were encrypted. And if they were not, it would give a not compliant AWS config event. And from here, that would trigger to Amazon CloudWatch events. From Amazon CloudWatch, we actually synced it to work with Amazon SQS so that they publish to an SQS queue. And from there, those queues would push to their SIM tool. So overall, this was the full solution that we architected and implemented for Change Healthcare in order for them to leverage AWS Secrets Manager to use cross-account KMS keys so that the security engineers could manage, create, rotate, and disable any keys from their centralized security account so they could isolate any of those keys as they needed and monitor as they saw fit. So that was a lot. So you might be wondering, how can we make this easier? So that's something that Johnny's going to dive into a little bit, but wanted to give you a quick smiling dog break to help you process everything you just saw. But again, we are always constantly thinking about how we can make this easier for our customers. So Johnny's going to dive into that in a little bit later. So closing out on our customer use case. So what were the outcomes for Change Healthcare with this solution? So there were a handful of positive outcomes. But first and foremost, these are some of the most important. So with this solution, Change Healthcare was able to ensure that they had consistency in managing secrets across accounts and organizations. Prior, they had different policies, different implementations for different teams, and it made it really tough to have visibility. So this did help security teams increase the visibility into the AWS service usage and use of secrets, as well to help them prevent any suspected abuse and detect any non-compliant resources that they had in their account. So again, this was going to allow security teams to prevent keys from being modified or disabled so that they could limit the scope of impact from any adverse events. Additionally, their past way of rotating credentials did essentially mean that there was going to be application downtime. However, with Secrets Manager, you do not have to worry about that. So there was decrease in application downtime, and also they were able to adhere to their HIPAA compliance and industry standards. So one of my favorite quotes that embodies some best practices of AWS Secrets Manager, "If you want to keep a secret, you must also hide it from yourself," by George Orwell from 1984. So this relates to the no hard-coded credentials in code best practice, which AWS Secrets Manager helps customers to achieve. So we're going to give you some best tips on how you can use AWS Secrets Manager to enable replacing these hard-coded credentials in your code, which includes, again, passwords with an API call to Secrets Manager to retrieve the secrets programmatically. So I'm going to dive into some of the common questions we received around using custom backend resources for rotating secrets, as well as how to access these cross-account KMS keys in AWS Secrets Manager. So one of the common questions we got was, what if we don't have a backend resource that is integrated with AWS Secrets Manager? The great news is there is custom Lambda rotations. So I'm going to walk through that. So again, AWS Secrets Manager enables you to configure database credential rotation on a schedule. So if you have a custom back-end resource that isn't already integrated with AWS Secrets Manager, you are able to set up this custom Lambda rotation. So from here, we have a rotation event. So let's say you have your 90 days come up where your secret needs to be rotated. That's going to cue AWS Secrets Manager to start the multi-step rotation where it's going to create, set, test, and finish with this AWS Lambda function. So it's a custom Lambda function that you write so that you can connect to your backend resource. So from there, it's going to connect to the backend resource. So again, this could be a third-party API key or a database that is not already integrated with AWS Secrets Manager. And from there, it's going to take the new credential. And as you can see on number 4, it's taking the new credential and it's promoting it to active. So from here, your code can then retrieve the new secret from AWS Secrets Manager. So again, super easy way to create that custom Lambda function so that you can integrate AWS Secrets Manager with any custom backend resources. Some other questions we get are, will rotating the database impact open connections? No, because authentication is happening when a connection is established. So when AWS Secrets Manager rotates a database credential, the open database connection is not re-authenticated. So it's a great way to integrate with all different types of backend resources that you need to rotate your credentials. Another aspect that we came across with this implementation that I thought would be a good tip to include in this session is, where is my cross-account AWS KMS key? So when we were implementing this with Change Healthcare, the team was using the console, and they went to click in to the console to select their KMS key from across account, from the centralized security account, and the key wasn't there, but we knew we had the right permissions. So what was up with that? We actually did some digging, and we found out that you need to have AWS CLI access and to essentially pull that from the CLI in order to encrypt your secret with that. And don't worry, if you've already created secrets, you can just re-encrypt it with your cross-account key using the AWS CLI. And we actually do have a reference slide in the deck that you can configure your keys with the CLI, so you can reference those at a later time. So again, when we went over that solution, that was a lot. It was a little overwhelming. So we dove in more to see how can we make this easier for our customers. And so AMS came up with a great solution that Johnny will dive into next.
Yes, thank you, Sarah. That was great information. So as Sarah mentioned, we are obsessed with customers and we want their feedback to help us deliver new products. So again, my name is Johnny Ray, and I'm with AWS Managed Services, and I'm going to just provide you with a brief demonstration of how Secrets Manager has been implemented for AMS customers based on their needs as they migrated and onboarded to AWS. So the customer challenge that we had for the AMS customers was that they, as Sarah had mentioned before, they have hundreds of accounts and they have hundreds of teams, and they were looking for a method to achieve management of all of their secrets using AWS Secrets Manager. And to help them do that, the AMS developed a secrets management. AMS developed a pattern to help customers enable Secrets Manager at scale while complying with their security guardrails. So some of the challenges that we had that we addressed with the use case was centralized management of IAM roles and permissions, centralized management of the AWS KMS keys for encryption, and restricted execution capability for AWS CloudFormation templates. So we'll go into those in more detail shortly. So just to give you a brief overview of the AMS pattern, I wanted to go through the elements. So the first thing we did was we utilized the AWS Cloud Formation template. And that template would then use a Lambda function to call on AWS Secrets Manager. From there, the secret would be updated in the Amazon RDS database. Then we would use AWS config to actually check for a state change in the database, use CloudWatch to ensure that the change was implemented successfully. And finally, we would use Amazon SNS topics to notify the customer if there was a failed rotation. So this allowed us to basically implement a secrets rotation for the customer at scale across hundreds of accounts without them having to scale up their personnel. So with that, the first thing we're going to do is we're just going to go into we're going to go provide an overview of how the Secrets Manager was working. So the pattern works, and we decided to use a video for this for the sake of time. So here we're going into the AWS Secrets Manager. You can see the dashboard here. And what we're going to do here is just kind of walk through the process itself. So from here, we're going to click on Secrets. And we already have a demo set up. So we already assume that there's a database in place and that the customer has migrated over static secrets and they need help transition those static secrets into to enable auto rotation, so their secrets will be rotated automatically for them. So you can see here that we're just going down, and you can see right now the rotation configuration is disabled. At this time, the customer does not have a rotation set up, or they don't have a rotation status set up, so that the secret is static and has not been rotated. So what we want to do now is go to Secrets Manager, enable that auto rotation, and we'll look at a brief overview of how to do that in the next video here. So we're going to go to the instance rotation, and then from there, what we basically want to do is look for the stack information, which we can see there. And I believe this may be a repeat of the other one. All right, so here we are. We want to create a new stack. And with the stack, we already have a JSON file that has been pre-configured for use, and you could get that the pattern details if required from the AMS library, which will be shared later. So in here, we're going to first specify the stack name, and in this case, we're just going to call it my auto rotation demo. Next, we basically want to configure, for this, we're going to configure the config rule so that we can monitor for that state change as mentioned earlier. We'll specify a time of 14 days for the rotation. We'll need to specify an SNS topic. So with this, we assume that this is the account has already been configured and you have an ARN that you can use for your SNS topic. And then we also need to specify the ARN for your Secrets Manager. Specify the security groups for the VPC that you're enabling this for, and then you just go through next. This is just a quick verification. Verify that the settings are what you expect, and create the stack. So going to the next slide, you can see for a shortcut, you can see that it has already been configured. So here we can just see again that the stack was successfully created. Next slide. Okay, so now Now that the secret has been automatically basically configured to rotate, we're just going to go through verify that the rotation has now been successfully created. We'll basically scroll down, and here you can see rotation is now enabled. Rotation is specified at 14 days as we had previously configured, and that value is completely customizable. It could be 14 days, 90 days, or whatever the customer requirements would be for their rotation. All right, and then for this, we can go through and just to verify, you can see that we have a secret. So in this particular case, it's a randomly generated password for a non-production account. Felt perfectly fine, showing like yeah, you can see the password there. Once you have that password, you can rotate the secret immediately, or the customer can retrieve that for use for the application. All right, so going to the next overview here. We're going to verify that verify that the Lambda function was able to successfully execute. And if you want to verify that, you can go to the actual function that which the actual Secrets Manager rotation function. And we're just going to give you a brief overview of what that looks like here. So scrolling down, we can view the logs in CloudWatch. And CloudWatch is going to have the actual the Lambda writes the state of the function into CloudWatch, and you can see here it's successfully signed into the MySQL database, successfully set the password, and successfully put the secret, place the secret for the iron. So we can see here that it was able to successfully complete each part of the pattern, and once complete, it updated the password. Next slide. And finally, what we'll do now is we're going to go to config, and we're going to, within config, we're basically checking for that state to verify that the secrets manager was able to successfully set that password. If it wasn't able to complete it successfully, what basically happens for our customers is that it will notify them. So the first one checks and verifies whether the secrets rotation was successfully rotated. If not, it will notify the customer. The second one actually checks whether the resources have the tags that was specified by the customer to keep that auto rotation in place. So if someone were to mistakenly modify or delete a tag, you would also be notified. And finally, the third checks that the maximum allowed rotation frequency parameter, or the frequency at which it changes, has been specified. So basically, again, just checking that the rotation is enabled. Okay, next. And now I'll hand it back over to Sarah. She'll provide some additional information.
Awesome. Thanks so much, Johnny. That was a really great demo, super informative. And to close out, so we have a great reference here from our customer, Zig, who is the Vice President of Infrastructure and Cloud Operations at Change Healthcare. So essentially by using customer enablement services with AWS, so that's AWS Professional Services and AMS, Change Healthcare was able to implement their solution to help meet their business needs for their compliance and security, which accelerated their migration and their exit from their data center to AWS so that they could better meet their needs for innovation and agility. So some key takeaways. So remember, as you're building out your AWS accounts, you're going to want to make sure that you're scaling your organization while securely protecting credentials. You also want to make sure that you're centrally managing and rotating credentials to adhere to security best practices and any industry and compliance standards that your business needs to adhere to. And lastly, ensuring least privilege permissions internally as well as externally to any partners or MSPs for the secure transfer of information. So lastly, here's some additional resources that if you want to dive deeper, you can essentially see some of the additional resources for the user guides, API documentation, and some blogs to walk through some different best practices around AWS Secrets Manager. You also joined this session to learn, so you can keep learning with AWS and beyond, and different resources from AWS training and certification. So according to Global Knowledge, IT decision makers report having the most difficult time finding qualified cybersecurity talent. So training has never been more important. We offer more than 25 digital and classroom courses for you and your team around security, identity, and compliance. And you can also choose to showcase your expertise by pursuing the AWS Certified Security Specialty certification. So thank you so much. Really appreciate you tuning in, and we hope you have a great rest of your day.